Now, without further delay, let's begin today's event, sponsored by Verato and hosted by Health Data Management. I would like to introduce your moderator for today, and that is Jim Erickson. Jim, you have the floor.
Thank you, and hello, everybody. Welcome to our session today. Glad you all could join us. Good morning, good afternoon, wherever you are. We're going to talk today about improving patient matching, important operational consideration and occasional bottleneck and sore spot for a lot of organizations trying to manage their healthcare data and their patient data. So my name is Jim Erickson. I'm going to be moderating our session today. Some of you may know me as a contributor to Health Data Management. I was a long-time editorial director at Information Management Magazine. And nowadays I work as a market research analyst studying a lot of these issues, including areas of governance, reaching down into areas of data quality, certainly things like data preparation, patient matching, things like that fall under the rubric of all those data management disciplines. So I've been looking forward to this conversation and an update today. I've met some of the folks from Verato before and really enjoyed learning some details of this work from them. You're going to be hearing from two speakers today. First, Mark Leroux, who's the CEO at Verato. He was at MicroStrategy for 14 years, where I imagine we crossed paths before, partner at Ernst & Young, and he's going to lead things off for us today. And you're also going to be hearing from Joaquim Nato, the Vice President of Healthcare at Verato, who I've had the pleasure of working with before. Also, good guy with boots on the ground experience in a lot of these issues around patient matching. So I'm going to be taking some notes, and I encourage you also to do the same. So we will reserve whatever time we have left at the end for some Q&A. So any questions you want to ask, be sure to get them in. And if we don't get to them today, if we run out of time or something else, we'll be happy to follow up with you. We are recording this session, and we will send you a link to the playback of that session as soon as it's available. I believe the slides are also available today for download under the resources folder at the bottom of your screen there. And if not, we'll also include those in our email to you with a link to the playback we'll have for you as soon as available. So I'm going to duck away now and hand things over to Mark Leroux, the CEO at Verato, to get us talking about improving patient matching in 3 steps. So Mark, why don't you take it away?
All right. Thanks a lot, Jim. I appreciate it. Appreciate the introduction. And thanks, everybody, for being on the line with us today. Thanks for that introduction. Let me just introduce the company very quickly, and then we'll get into the very meat of the presentation, because I know that's what everybody dialed in for. By way of overview and background, so Verato, the sponsors of this webinar, we are a venture-funded company exclusively in the business of patient matching. The company was founded on that idea and improving that idea in a dramatic new way, which we'll be describing to some extent in this presentation, although, again, this is not purely a commercial for Verato. It's a general presentation. But we have been in this business for quite a while now, and we've accumulated a good number of customers, major providers in the space, but also HIEs are taking advantage of referential matching that we provide. And though not shown here on our select customer list, we also have a number of payers as well. So it's across the spectrum of healthcare that people are interested in better patient matching. Now, let me give you a quick overview of what's going to be in this presentation, because I always appreciate when the speaker tells us everything we're going to hear before we hear it, just so that you can navigate yourself through the next 40 minutes or so. Well, here are the primary messages of this presentation. So first and foremost, it's the fact that patient matching is becoming much more critical. It is critical, and it's going to become even more critical to every facet of healthcare going forward for a lot of reasons. And we're not going to go into all of the reasons, but we're going to put on the table that everybody's job and the mission of patient matching is expanding somewhat dramatically, and we're going to paint that picture. That's the positive side of the equation. The sort of negative side of the equation is that the conventional matching technologies that we're using are struggling today, maybe perhaps not failing, but as new needs come down the pike and are imposed upon those conventional matching technologies, they're going to be stressed to the point of the breaking point. And even today, by our estimation, that 20 to 30% of all potential patient matches are missed, either within an organization, and the number is even higher across organizations. The third major point of this presentation is that there's a new technology called referential matching. that can be used in place of or to supplement your existing conventional matching technologies. Either way, it can be applied to significantly improve patient matching. And that's largely what Joaquim is going to talk to you about. He'll talk to you about real use cases for referential matching in existing organizations at different levels. This referential matching has existed for a while. The new techniques around it revolve around the fact that it can be cloud-based and operate at very, very high scale, in fact, nationwide scale. But probably the most important message about referential matching, and I think I've already mentioned this, but I'll repeat it because it's so important, is that it can be implemented at 3 different levels, and we call them crawl, walk, run, where crawl is the simplest thing that you can do, gives you modest value at very high speed, so very quick to value, and it can help you understand, as it says here, it can help you diagnose your existing MPIs and MDMs or EMR products. The walk strategy does a little bit more. It's also very quick to implement. Joaquim will describe that to you. The majority of Verato customers are doing this walk strategy, supplementing their existing MDM or MPI product. And then the run strategy is to commit to doing all of the patient matching using new referential matching techniques. So that's going to be the meat of the presentation. We'll get there relatively quickly, but I will spend just a little bit of time to build up the necessity of this kind of new matching technology. And to set this up, I guess it's really important to state that everybody is at a different point in their patient matching life cycle. And here's a simple diagram that perhaps encapsulates one vision of this life cycle. And what it describes here from left to right, something of an increasing level of sophistication or consolidation of the patient matching discipline. At the far left are people whose strategy around patient matching revolves largely around a single product, your single EMR product with its built-in patient matching technology. And historically, this has been what people started with, and again, historically, that patient matching technology was quite rudimentary because it was, 1/20th of the functionality of the EMR that you were purchasing. But nonetheless, an important piece of functionality. Quickly, people outgrew that and found that they needed to supplement what they were acquired through their built-in EMR matching technology, and that's where the homegrown patient matching solutions came into play. People implemented purpose-built data warehouses with homegrown matching technology that did a better job, a more sophisticated job of matching patient attributes than was built into the earlier EMR products. But as people outgrew that, and they had more mission-critical consumers of patient matching within typically the provider ecosystem, many hospital systems found they had to purchase third-party MPI products for specific use cases. They still had one main MPI, typically embedded or built into their patient matching, built into their EMR product, but they had to supplement those with third-party MPI products for new, important, specific use cases. As those built up, it became clear to everybody, or not everybody, many people, that yet a higher level of matching was required, and that sort of augured in the era of enterprise MPIs. Large vendors now, IBM, Informatica, Nextgate, provide these eMPIs to sit above all of customers' existing, or all of a providers' existing patient-generating systems. And so this is a sequence, and it is somewhat linear. It kind of is a timeline, but frankly, if I was to redraw this diagram, I might draw the head of this chevron reaching right back around to the tail again, because we're going through an era now where through Epic and Cerner and some of the other large EMR products, companies or providers are reestablishing a strategy of basing all of their patient matching on their core EMR products. So indeed moving away from the eMPIs. So this is one of these things where nobody's found a good stable point for patient matching for a few reasons, which I'll speak to in just a minute. But to allow the audience here to participate to some degree and to teach each other or give each other a little bit of insight as to where we all stand, what I'd like to do now is to switch to a poll. I'd like to turn it over to Jim and let him run the simple poll that basically asks you the question, where are you along that life cycle? So Jim, can you run that for us?
Yeah, exactly, Mark. Thanks. And yeah, I would like to ask this one question for you today, as I think the only one we have. Where are you today in the patient matching life cycle? If you can please select one of these answers what Mark was describing built in, the patient matching in your EMR, homegrown, something that you built on top as an integration layer or using a data warehouse, added use case specific third-party technologies for specific use cases, or full-blown enterprise MPI of the full enterprise-wide deployment used by all systems and all use cases. Be curious to see how many of those there are out there. But to Mark's point earlier, I really do get and agree with his finding that people are all over the map on this, and our research also bears this out. So if you could select one of these options, please, and hit the submit button. I'll give you just a minute to finish doing that. And remind you that we're recording this session and that I am taking some notes. I've already got a couple questions for Mark and Joaquin toward the end of this presentation today. So again, pick one of these, hit the submit button. I'm going to close the survey in 3, 2, 1, and let's take a look at the results. Oh, okay. Well, Mark, you're looking at this. It looks like they're kind of across the board, like you said. People are kind of at all stages of this journey on patient matching and trying to reach forward and do a better job of it, and some folks still on the trail there.
Yeah. No, that's exactly. Thanks, Jim. Thanks for running that for us. Thanks, everybody, for filling in your survey. Yeah, this is emblematic of the situation. People are at all different stages of this life cycle and sophistication. And as I mentioned a moment ago, I think probably we're going to be wrapping ourselves back around to the beginning of this chevron as well. Well, let's talk about why is there so much diversity and strategy on how to approach patient matching. Let me go back to the fundamental problem of patient matching. The fundamental issue here is that it's all about the data. If all of the identity information for all of our patients were correct, complete, and up to date, there would be no patient matching problem whatsoever. We all know that. But the real situation here is that there's a sort of a fundamental problem with identity information. It's almost like it's one of the laws of physics almost, that identity information, by its very nature of its collection, the fact that it's got distributed ownership of individuals, privacy is wrapped up into it, that by our estimation, and by a lot of people's estimation, that at least 30% of all the demographic data in master patient indexes is either incorrect or it's out of date or it's incomplete in a very core way, which impedes matching. And these all happen for very obvious and natural reasons. Data changes over time, we know that. There are inherent errors in the collection of the data, spelling errors, transcription errors, typing errors, homonym errors. There's inherent incompleteness. People do want to protect their Social Security numbers. Sometimes they even put in the wrong one just to protect theirs, or they put in a default 111111 for their Social Security number. And there are a whole host of ambiguities that crop up in MPIs, issues where two identities are so close typically, or the characteristic of the data is not natural to be captured in a standard way by a computer system. This happens with a lot of the cultural naming conventions that MPIs have to deal with, Hispanic names, Asian names, classic American or European names. So all of these things together impede our ability to have perfect data within the MPI. And it's not just the fact that the data is bad, and bad is the wrong word. The data is the data. It's impossible to call it bad. That's sort of a natural state of identity data. Now, the MPIs that we've built or bought or installed through our EMR vendor, their job is to put together identity inputs from multiple sources, from the registration system, the revenue management system, the pharmacy system, the lab system, puts all of this together to make sense of it and to determine whether all the Mark LaRoes that are being accumulated and captured at these various endpoints coalesce to the same Mark LaRoe that's within the MPI. We know that's the mission of these MPIs. But we all also know that these MPIs are somewhat brittle, meaning the way to get them to work well is to tune them, and tune them to a very high degree to the characteristics of the data that's being fed to them, and to tune them to the business imperatives of the institution that's using them, so they can put more or less emphasis on different kinds of matches based upon the business impact of either a correct match or an incorrect match. So all of this tuning and setup and governance committees goes into making our MPIs work as well as they are today. But let's all face it, the way they're working today is somewhat on a tightrope. You move the system a little bit in one direction or another direction, and suddenly lots of things start breaking. Matches are being missed, or worse, false positives are being generated. And the IT team or the data governance team has to jump on it and try and correct the situation. Now, unfortunately, the nature of healthcare today is such that it is in a high state of flux. We can't live with technology that lives on a tightrope. In fact, what's going on today is there are many more systems that want to plug into and use the MPI. So not just use it, but add identities to it. And there's a truism about identity data. That is that the more identity data that feeds into a single consolidating system like an MPI, the degree of incorrectness or errors within that MPI compounds. So one incorrect injection of Mark LaRoe into that MPI in the middle there from one of these new dark blue squares can suddenly corrupt all of the Mark LaRoe records that exist within the MPI. In fact, two Mark LaRoes might appear. And some of my records show up on one Mark LaRoe, the other ones show up in the other Mark LaRoe. And then if the incorrection is big enough, maybe another identity gets laid on top of one of the incorrect Mark LaRoes. And so suddenly I'm also getting Mary LaRoe's information. And the problem begins to accelerate. And this is a problem in data. Anybody who's worked in data for any length of time knows that the more the inputs, corruptions and incorrections compound rather than work themselves out. And so it's not just that more systems are using the MPIs, but the MPI itself has more use cases. Interoperability between providers, advanced analytics. The MPI becomes the cornerstone or one of the major projects around any hospital consolidation or merger. So not only are we struggling with today's data in today's MPIs, but the demands we're going to put on these MPIs are growing exponentially. And what's, I guess, more what is also sobering about that situation is that the people, specifically the executives who have a stake in the MPI, they probably are now at least 3 major stakeholders and probably more, where maybe 5 years ago or 10 years ago, you couldn't get a CEO or a CMIO to spell MPI. They didn't even know that technology existed. Now they know it exists, and they know it's the root of many of their strategic goals. You see a list of strategic goals here under the CEO, everything from improving patient experience, a strategic initiative, improving population health, a strategic initiative, fundamentally reducing costs. The CMIO has his or her own strategic reasons for having that MPI work well, and the CTO has his or hers. So many new stakeholders, high levels in the organization, with strategic initiatives depending upon it. So, in a lot of ways, this is a recipe for great career advancement. I mean, if you feel like you've ever been marginalized because you're responsible for patient matching and you never get the same visibility as the leaders of other major systems or other initiatives, the good news is that era is passing quickly and you are squarely in the bullseye of many new initiatives. And that's both good and bad. It's good if you get on top of it, and it's bad if your technology falls short for you. Speaking of technology, we all know, or if we've been tracking the news, this past year has been a major year in terms of trying to solve the patient matching problem. In fact, two very well publicized and very well participated in challenges took place last year. One from CHIME, the College of Health Information Management Executives, I think. They had $1 million prize called the National Patient ID Challenge. It was suspended finally in, I think, September after 2 years in operation, wherein they were looking at all sorts of new technologies to see if it could break the logjam of patient matching. Equally, healthit.gov, also known as the ONC, or the Office of the National Coordinator, also ran a challenge, but theirs was very specifically about patient matching algorithms. So not even trying to introduce new technologies like biometrics and blockchain, but bread and butter algorithms. And this contest actually came to a conclusion, but the conclusion proved something that we kind of already knew, which was that current algorithms can work quite well so long as the data errors fall within a very predictable range and you are willing to add a good amount of manual effort and a lot of tuning to make it work. But this just brings us back to that original thesis I mentioned, which is that MPIs can work well today, but they're brittle, and they need a lot of tuning and a lot of work to work reasonably well. So let's find out what is it about the data and matching that is so problematic. And I've got a series of 3 slides here, so be prepared for a couple of builds. But look at this picture for a second. On the bottom axis, we're talking about the differences in the demographic data between 2 identities that your system, your MPI, must determine whether it's the same person or not. And quite frankly, the difference in demographic data between 2 candidate identities ranges from something that is very subtle, very small differences, or at the other extreme, very radical differences. And then the frequency that this occurs, most of the errors occur, or most of the differences in data we have about people actually falls largely in the middle. And in fact, most of the errors, and the good news here is that our current algorithms handle these kinds of errors very well. And the kind of errors we're talking about are illustrated here in the example at the bottom. Here's Catherine Smith on the left side with 123 Main Street. And on the right, we have Cat Smith at 132 Main Street. Same birthday, same Social Security number. And so that's a classic example of a number of demographic data elements that are in disagreement, some data elements that are in good agreement, but the disagreements are easy to calculate that they could happen in a very natural way, and our probabilistic matching systems can see beyond those kinds of errors. That's the good news. The bad news is that, so a normal system would show this as a match. The bad news is that there are an awful lot of errors that occur that represent the same person, but there are very radical differences in the data that's presented for that same person. And here we have Catherine Smith at 123 Main Street with a certain Social Security number there, 123. And then you have Cat Johnson. So Catherine Smith apparently got married. She became Cat Johnson, or she changed her name for some other reason. She moved to a different address, maybe even in the same town, the same zip code, so those things can be completely the same. Same birthday, so you suspect it might be the same person, but because so much of the data does not agree, there's no matching system in the world, at least not probabilistic matching system, that could ever declare those 2 people to be the same person. So this would be a no match, but indeed, as I've described the problems here on this call, these would be the same person, and so that would be an incorrect call. By the same token, there's a whole raft of errors that occur at the very subtle end of this bell curve. Here we've got Cat Smith, 123 Main Street, a birthday, a Social Security number, and this person differs from Pat Smith on the right-hand side by 1 letter in her first name, I assume it's a she, and 1 number in his or her Social Security number. And obviously this is probably a twin situation. In fact, if these are the same different people, it most assuredly is a twin. There's a chance that it's a parent-child overlap with the incorrect birthday, but that's highly unlikely. But there are a lot of situations like this. There are twins and parent-childs and just people with very, very common names living in the same apartment building. You just have a high probability of getting the same birthday, no Social Security number, the same address, and the same Maria Garcia name. It just happens, particularly in dense urban areas. So the issue here is that probabilistic systems can't see through the 2 tails of this bell curve, and the 2 tails of this bell curve together might account for upwards of 30% of all the matches presented to our EMPIs. And that's where human beings come into play with their various research tools. But I'm here to tell you that there's now an automated way to tackle those 2 extremes of the patient matching bell curve. And the key to this is to have a reference database. That's why it's called referential matching. And a reference database is populated with identity data, typically from sources that are not healthcare, so that it doesn't have the same accumulated errors that the healthcare system has accumulated. So we pick up errors that are accumulated elsewhere, credit, telephone company, governmental and legal records, but you flow billions of records in from multiple other institutions and other means of gathering identity data, populate a reference database, apply a very significant amount of data science and data scientists' work to clean up, consolidate, clarify, rate every element of data that populates that reference database, And ultimately, you end up with a database of over 300 million people in it, with a large historical tail of data, of identity data or demographic data of those people, that's constantly being updated every month. And it's that reference database that acts as the answer key for referential matching queries. And I'll show you 2 slides on how that works, kind of illustrating both ends of the bell curve. So here with referential matching, here's a situation, the first example I gave you, with Catherine Smith on the right side and Cat Johnson on the left side, Cat Johnson on the right side. Within the reference database, there's a record for this human being. And the name of this person is both Catherine Smith and Cat Johnson. The referential database knows that this person, the same person, has changed her name. Presumably she got married, has changed her address, has the same birthday and the same phone number she did before. So when the matching takes place, instead of comparing Catherine Smith to Cat Johnson, as you would normally do with a probabilistic matching system, Catherine Smith maps to part of the reference data or the reference identity. Cat Johnson maps to other components of the same reference identity. And because Catherine Smith and Cat Johnson both pointed to the same person within the reference database, they are the same person. And by the same token, the opposite works as well. Here we have the twins issue that I described earlier as part of that bell curve. Cat Smith on the left side, Pat Smith on the right side, 2 twins living at the same address, same birthday, very similar Social Security numbers. Within the reference database, because each of these persons will have gotten separate phone numbers, they will have gotten separate credit cards and had other credit queries called upon them with their very specific information. The reference database indeed knows of them as 2 separate individuals. And so instead of matching Cat Smith to Pat Smith directly and believing that it's the same person, a referential matching system would have compared each of those individuals to each of the individual references that already exist in the database. So the solution, or the idea of reference matching, is no more complex than this. In fact, I'm happy to say it's as simple as this, because in simplicity there's power. This is an extraordinarily powerful concept. And it takes the guesswork out of the vast majority of the hardest matches that providers and payers and HIEs have to do. And in fact, I'll just wrap up my presentation with this one last slide and just make the claim that, or make the statement that the full referential matching system that supports healthcare institutions today is based upon big data with this reference database that I just described. It's the answer key, and it's the critical component. It has hundreds and hundreds of millions of identities in there with 30 years of history of data and very complex algorithms for keeping track of which data elements are most current and most correctly associated with a given individual. And then to go along with that big data database, there is the referential matching algorithm itself. The beauty of this algorithm is that it doesn't have nearly the same tuning requirements that probabilistic matching does, yet it's more accurate, and it requires less stewardship, less intensity on getting all of the identity data across the various systems that are feeding it, that are feeding the MPI, correct. Because the referential matching system combined with the big data, it can see through many more errors. It can see through time. It can see through geography. And then finally, it's a SaaS-based system. It almost has to be because the database is so large. There's no way you could house it on-prem in any secure way. But that said, the huge advantage of being a SaaS-based system is that it is infinitely scalable, and customers can simply plug in. They just plug into the APIs. HIPAA High Trust Certified makes it secure and begin using it. So it's very fast to turn on and get going. So that's kind of the basic premise. Why is probabilistic matching under stress right now? And why is referential matching a solution to that stress, at least theoretically? I'll turn the podium now over to Joaquin and let you talk to you about how it's practically done in real companies. So Joaquin?
All right, thanks, Mark. So let's get right into that. Let's talk through these 3 ways that you can that you can use this referential matching approach, distinctly different approach to solving this patient identity problem. So Mark teed this up at the beginning, and I'll just walk through and kind of break these out, give you some real case studies for each of these, the types of clients that are doing these and what situations they're in, across a variety of different types of healthcare organizations. As Mark mentioned, we're being used, Verato specifically, and in general, the referential matching idea, across the provider, the payer, the HIE sides of the equation. Lots of technology vendors are working with us to deploy this, new approach. So I'll walk through this diagnose idea, the crawl step. So if you're trying to size your problem, determine if you have a problem, how you can use the technology to do that, how you can automate existing processes that you have. So this is pretty cool. You can basically plug in referential matching on top of your existing identity processes and get some very quick value. And then how you deploy kind of a broader solution. Basically use this as your identity matching approach across your organization, and get the advantages of this sort of much simpler and better solution that's now available. So let's start with crawl. So why do you crawl? So as I mentioned, the most common reason is if you don't know what the size of your identity problem. So if you don't know what your current duplicate rate is, you don't know your overlap of patient records across multiple EMRs if you have more than one, or if you have folks in the organization that don't think you have a problem but you haven't actually measured it yet, then you probably want to measure it. And so we see a lot of that. It's kind of split down the middle. A gut instinct that you could be doing better in identity resolution. Maybe it's because of anecdotes of issues that get brought through HIM that people have to resolve, or it's just knowledge of the amount of effort that you put into this, and you want to quantify where you're at today. So the drivers behind wanting to do this, I did just want to circle back to this. Mark introduced this concept of the increasing kind of scope of patient identity, both in terms of the data that's being input into your systems, and just kind of tying a little bit back to my experience. I started in and around this space 10 or I guess more like 15 years ago now. And if you just think about the data landscape, how it's changed over the last 10 or 15 years, it really is pretty unbelievable. The number of new sources of information that organizations are trying to integrate, the systems that can actually absorb all this data, the analytical systems, the health apps that you get out of your phone. This is a very real concept, this idea that there are many more data sources, lots of more data that's available for you to use to improve patient care. And it really is making the scope of the problem much worse than before, but we haven't adjusted to it in terms of the patient identity processes. So we do see a lot of people who are saying, hey, with all these new data sources, I really got to see how well I'm doing and figure out if there's a way that I can do better. So how does this process work, this idea of diagnosing your current state? It's a really simple thing that we use the referential matching technology for. Basically, you can take a snapshot of your current patient identity system. So it may be an individual EMR, you're a complete Cerner shop, and you've done a good job of consolidating on one EMR. It may be that you have an MPI in place, legacy MPI that you are using as your master patient identity. You can take a snapshot of that. Or even if you have multiple EMRs that you have not integrated and put together, you can basically take snapshots of either of those, simply take an extract of that file, send that to Verato, and we can run it through this diagnose process. What you get out of it is you basically get this report on your true identity state, true number of duplicates that you have. So after running this through the referential matching process that Mark described, and I won't revisit the sort of the inner workings of that, we basically will generate a report for you, and it'll give you this answer. You have a 12% duplicate rate. You have a 18% duplicate rate. Something that's actionable for you to start building a plan around how you can improve your technology and/or processes to improve. One thing that is cool about the way we do this with referential matching is because it's not just a probabilistic matching exercise, it's using this reference database as the answer key. There are some interesting things that we can do that provide some additional insight into your data quality. So, organizations are always asking us, okay, we found what our error rate is, and we understand how referential matching can help us resolve that. But they want to go deeper and understand why that is. So what is it about the data quality in their particular systems? Obviously deploying referential matching will make a big improvement, help them address that problem. But there are also other things that you can do to improve the quality of data that you're entering and capturing about your patients. And because we're doing this comparison against this answer key, there's a whole different type of perspective and statistics that we can give you that are really useful as part of this diagnose process. So an example, and like each of these crawl, walk, run solutions, there's a really wide spectrum of organizations that can benefit from this. So, ranging from, small health systems, local HIEs, to statewide organizations or very complex, some of the largest payer organizations. No matter what kind of part of the healthcare ecosystem you're in or how big you are or what your landscape looks like, you may be struggling or probably are struggling with this patient identity problem. So this is an example of a smaller county HIE who had actually spent a lot of time and energy over the years investing in some homegrown patient matching. They really got some experts in the field to work on this, but they didn't know, and they thought they were doing pretty well, but they didn't know. And so they wanted to get that proof point. And so we did this diagnose exercise for them, identified that they had a 15% duplicate rate, and not only allow them to quantify that, establish kind of the baseline for where they were, but then actually take the results and help them improve that and resolve those issues that were identified in this diagnostic analysis. So the process I kind of mentioned before is pretty straightforward. Kind of extract some data, provide it to us in a secure mechanism, which we've got very robust processes around. You have to do that, and then within a couple of weeks you get this full diagnostic report that lets you understand, quantify the current situation, and then even act on it to begin addressing that and actually improving the data quality that you have. Okay, so that's the crawl, kind of baseline, assess. If you don't know where you're at, start there is the idea. It's actually a more common starting place for us, for clients that we work with, is this walk stage. So, most organizations have invested various degrees in solving this problem. You may have an EMR that has a work queue of potential duplicates and an HIM staff that manages those. Likewise, you could have the same situation with a prior investment in some MPI technology. And either you have lots of staff that are allocated to addressing this problem, or maybe you just have a long list of items in your work queue. And we see that all the time. This is something that lots of organizations measure and track, is the size of their backlog of identity tasks. And it's also something that's very easily quantifiable. So we find that lots of organizations have good visibility into this, and it's not so much a question of, well, what is the size of my problem? How big is it? It's more a question of, hey, how can I most efficiently solve this problem? And if that's your current state, then you're kind of immediately in walk mode. So you've got this team of stewards who are spending all day working these tasks, and that's a high cost. And if you can improve their efficiency, make them available to do other important data quality tasks, then that's a big win. Or if you are a organization that maybe you don't have the luxury of having a large HIM staff, and you have simply this backlog of tasks being created but no one to work them. That's another situation we encounter a lot of times. Those are two just sort of easy to read situations where it's clear that there's this existing process you have that's building up this set of actions to take, and if you could automate that, then there'd be immediate benefit. And so that's the walk scenario. So what does this look like? The walk scenario, a process that we call auto steward, basically automatically stewarding these tasks that are created by your MPI or your MDM system. You can do this in bulk. Most of the clients that we work with that deploy this end up doing it in a kind of a transactional basis, so using our modern APIs. And the way it works is you basically take these individual tasks and you call a Verato service and you're asking the question, I have two records and my current patient identity system said these two might be a match. It wasn't sure that they were that they are or not, but they might be. So instead of putting that onto a screen and having a person look at those and make some judgment assessment, you simply take that same concept, that same task out of the EMR or the MPI. You call our Verato service and ask the same question of the referential matching system, and what you get back is the referential matching answer, and each of those are categorized into yes, they're the same person, and there's evidence for why they are. Mark showed those examples of what it looks like when you have two different sets of demographics that line up against the same reference record. So you get those answers back along with some useful information. So the demands of HIM, data management professionals, there's a lot of data you need to support these decisions. And so this is kind of a very simple picture for what this solution works like. There's a lot of meat under the covers for what's happening when you do this kind of interaction. But it's a very simple solution. The outcome is that you get these answers back, and those can easily be integrated into your EMR or your MPI system, and basically dramatically reducing the load on whatever data management staff you have available to be doing this through the traditional mechanisms. So example of this walk scenario, we did some work just a few months ago with a health system who is an Epic shop, uses Epic as the enterprise EMR, uses Epic Identity as the patient identity solution. They had a team of stewards who was able to keep up with their kind of normal day-to-day operations. But like a lot of organizations, they're also in a kind of dynamic environment, onboarding new systems onto their Epic installation. So that's something we see all the time, is this migration idea where organizations have secondary sources. Either it's a new EMR, maybe it's a practice that was acquired, or some other systems that are being migrated in. And every time you do that, there's large volumes of records coming in, and that really accelerates how big the size of these backlogs of these potential tasks. So sometimes organizations, and these guys fell into this bucket, have enough staff to keep up with the day-to-day tasks, but not enough to keep up with any of these events as they are acquiring more data. So we integrated directly with Epic, did this concept, pull out the potential duplicate tasks. They had 135,000 of things that had been built up over a period of time and through these acquisitions of a different systems coming in, EMR systems coming in. And we're able to resolve 59% of those tasks through this referential matching approach. Basically, we got that queue, cut it in half, and got it to a small enough rate that their team could get through and resolve what's left. This is an example of the health system. Like I said, what's interesting about this sort of approach to deploying referential matching, this auto steward idea, is that it works equally well for small organizations that have, tens of thousands or hundreds of thousands of tasks, and maybe a couple stewards or no stewards. It works equally well for that as it does for very large organizations. When Mark started the webinar today, he showed some of the other clients that we work with, some very big organizations. Healthix and CRISP are two very large HIEs who are working with us using this auto-steward approach, where they have extremely large volumes attached just to the nature of the data, the number of systems they've integrated with. And so the idea that you can deploy this walk to auto-steward approach across lots of different profiles of organizations as far as their size and whether you have an MPI or an EMR is something that's pretty cool. Okay, so let's do the run. So run, this is, we talked about the assessing where you're at. We talked about layering in auto-steward into your existing process. So you have an identity solution, then you want to quickly put something on top of it. That's the auto-steward. Run is you want to take advantage of referential matching as your identity platform. So there are a couple different profiles that we see of folks that are interested in this. So the first is organizations that have already invested significantly in some patient identity technology in the past. So maybe you've purchased a traditional MPI in the past, and you basically know that it's just too expensive and not giving you the results that you wanted. When you add up the costs associated with the traditional way of doing things, we see a lot of organizations who have, done the TCO calculations, and by the time you look at, okay, there's, software license costs that you have, there's maintenance support associated with those. Implementations of traditional MPI technology are invariably, more complicated, take longer than you expect them to. So implementation costs, actually $2 signs is probably underweighting the cost of those. But when you take those things that are the things people usually think about with a software implementation, and this idea applies to just all software in general, not just MPI, but the idea that you have sort of license and maintenance and then implementation, most people think about those. Obviously, when you're comparing to a SaaS platform, things like hardware management, third-party software management, all those types of things add up as well. Those first four items on here are the things that people usually consider when they're thinking about TCO. With MPI specifically, we find that organizations who've been doing it for a while realize that the costs of tuning the algorithm, as Mark mentioned, of upgrading to new versions of software and then refactoring algorithmic rules, putting in new business rules, and then layering in on top of that the actual data stewardship costs and the number of people that it takes to deal with the exceptions, those are kind of the hidden costs, and those add up a lot. And so we have a lot of organizations who have this experience and have determined, hey, there's got to be a better way, a more effective way to do it. And so they're looking at our referential matching approach with the SaaS solution to do that. On the other side of the coin, there is just the simplicity angle. Again, as Mark kind of talked through, he talked through the how referential matching works, the uplift you get in accuracy just by the nature of how the system works. But one of the real practical benefits of that is that you don't have to do all of this customized implementation work. That combined with being on a modern stack with modern technologies and RESTful APIs makes it so that you can deploy this solution very quickly and get very accurate results, have no concerns about performance, all the types of things that you have to think about when you're deploying new traditional software, including for MPI scenarios. So that's what the other profile looks like. So if you're ready to invest in MPI, you haven't done it before, the idea that you can just quickly deploy this SaaS approach that's powered by this referential matching idea that doesn't require the same type of heavy lift to implement is really attractive. We have lots of technology companies, so other healthcare technology companies, population health vendors, data warehouse vendors, organizations like that understand the importance of getting the data lined up accurately, but also value kind of the benefits of good modern technology for getting this done efficiently as well. So The run solution looks like an MPI. So, you get out of the business of all the kind of deployment hassles you have for traditional MPI technology, but the integration patterns are essentially the same. You plug your interface engine and your EMR into the Verato services. Like I said, it's modern services that virtually all interface engines today can pretty easily integrate with. You call just a handful of services to do that. You get back our unique identifiers, which can be easily inserted into your business processes, either your EMR or downstream to warehouse and analytics environments. And you can be up and running, like I said, in just really just a matter of a couple months. A good example of this, and we did a webinar a couple months ago, just before holidays, with the team from Rio Grande Valley. Rio Grande Valley is a smaller HIE in Texas. They had decided to re-platform their HIE. They were on kind of an all-in-one stack. They wanted to have kind of just more agility for being able to deliver services to their their customers, which are the hospitals and payers in the region. And so they wanted to go with a best-of-breed solution. We ended up teaming up with a HIE technology called ForCare. It's a nice solution, and implemented in just under 4 months. Implemented this full solution. They estimated that was about half the time that they thought they'd be able to go live, and they also calculated a number of savings. So, how much did this referential matching idea save them in terms of being able to address these duplicates that they would have been encountered with a traditional approach. They also did a very clear calculation on that full total cost of ownership. So kind of considering those factors we went through a couple minutes ago, the tuning, the maintenance, the upgrades, all of those things that they were going to be able to avoid, came up with these calculations on savings. And the numbers, interesting, it was compelling for them as a small organization, but probably more important was kind of the manpower savings. And so just being able to integrate the solution, plug into it, have it run, and not have to dedicate significant staff who have lots of other things to be doing. That was really the big benefit that they see, and that's what we see with folks that are running for the Link solution. Is that it's good results with really a vastly significant reduction in the amount of just effort and overhead that you have to deal with. So there are a few places to start, based on the profile of your organization, where you're at, the diagnose, the auto steward, and the full MPI deployment. Like I said, the majority of organizations that we see kind of fall into the middle. We know we have a problem. We've measured it. We're looking for ways to fix it. They grasp pretty quickly to this idea of referential matching. And so the fact that there's a way that you can slot that in without a ton of effort and kind of get some quick, immediate value kind of makes the walking the most popular way to start.
Okay, Joaquin, thank you. This is Mark. Hey, Jim, do we have some time for a few questions to wrap this up?
Yeah, we have just a couple of minutes, and thank you both, Joaquin and Mark, for those presentations. Really a lot of information in there, and we do have quite a few questions. We're not going to be able to get to all of them today just for time, but we'll let you know. We'll follow up with you offline on that. So first of all, yeah, a lot of information there. One sort of technical question here, or actually just a performance question. Have you guys come up with sort of a baseline accuracy rate when you reconcile those duplicates? Is there any sort of baseline number you guys look at as in terms of performance of your service?
Yeah, I'll take that as well, Jim. Thanks.
Sure.
Yeah, the best. What we have done, we've implemented this auto steward solution a number of times against a really wide variety of situations. So the leading EMRs, Epic, Cerner, et cetera. Most of the MPIs that people have deployed, we've had experience doing the solution with. So it really does serve as a good kind of baseline set because as we've gone across those different areas, there's of course variation, amongst the different EMRs and some variation organization. But we've developed a pretty good track record for being able to resolve anywhere between 50 and 75% of those existing queues. So of the ones that the traditional technologies can't resolve, we're able to get well over half of them, up to 75% with some of them.
Okay. And real quick, for Mark, I'm really curious, Mark, because we only have a minute left, so it's not fair to ask this. But you mentioned things were going sort of full circle in terms of the built-in to homegrown, to third-party to enterprise, to EMPI, and sort of back to the beginning. I guess, are people saying, hey, EMR guys, your roadmap promised X, Y, Z, or why is the need for this, for Verato fit in the context of this continuum you showed us, from built-in EHR stuff to enterprise MPI? What's your spot in this whole continuum?
Well, yeah, okay, thanks. So, our spot in the continuum, it's almost as Joaquin said. Our biggest goal at Verato is to be able to allow anybody, no matter where they are in this life cycle, whether they're entirely dependent upon Epic or Cerner's matching, or whether they've purchased a world-class EMPI, we want everybody to be able to plug into referential matching and make their existing matching system work better. And that applies, that fundamental tenet of the company applies to wherever somebody is in this life cycle. You can have very rudimentary patient matching from an EMR product, but if you supplement it with referential matching, suddenly it becomes world-class.
Right.
If you have world-class EMPI operating, but it's still kicking off way too many potential matches, as they inevitably do, you can make that $2 million investment in IBM Initiate. You can make that investment finally worth all of the money that was poured into it by closing the gap, and that's our goal.
Right. Well, I get the point, and we're going to have to wrap things up there. I do appreciate it. I talk to a lot of chief data officers and a lot of folks out there who wind up doing a lot of remedial work on the back end, and I know I directly quote one of them as saying you'd rather have, high-quality data up front than a killer algorithm any day of the week. So I get the point. I think it's an interesting construct to put alongside sort of the analytic revolution, this notion of a very comprehensive referential database to actually to be the proof point of a lot of this analytic automation. So we're going to have to knock it off there. And again, we'll follow up with folks who weren't able to get to questions today. I want to thank our speakers today, Mark Leroux, who's the CEO at Verato, down there in McLean, Virginia, and Joaquin Neto talking to us from out in the West Coast, who is the Vice President of Healthcare at Verato. I want to thank everybody in the audience for your patience and with hanging in with us today for this session. I'm Jim Erickson for Health Data Management. Thank you all for joining us today. I hope everybody has a great week. So long, everybody.
Thank you again for joining us today. This does conclude today's conference. You may now disconnect.